Okay, let's do that part B. There's a couple things I meant to get to yesterday I didn't get to, so let's do those, and then we'll do some other stuff. So let me grab, what should I do first? Let's do the pyramid first. There's a pyramid. So I'm going to grab that, put that right there. Just grab this off the interwebs, right? I just say that to be silly. But anyway, here it is. Here's a pyramid. We didn't do this yesterday? No, we did a cone, right? What similarities does this have? Just looking at the picture, what similarities does this have? It comes to a what? To a point, yeah. They call this the apex. What did we call it yesterday? The vertex, yeah. Either way. But our book calls it the vertex. Some places call it the apex, all right? But if you look at it, look, a cone, if I get my shapes correct, a cone has a circle, right? And it comes to a point, all right? This one doesn't have a circle. What is it? It's like a square or a rectangle, okay? Okay, it's some kind of shape right here. They don't all have to be squares. They don't all have to be quadrilaterals. You could have a pentagonal pyramid. What is that? Pentagonal. What's the bottom of it? A pentagon. Very good. So the bottom would be 5 sides on the bottom. And all the sides go up and they all meet at a point. It would still be a pyramid, all right, but it would be a what? Pentagonal. What if the bottom was a hexagon? What would we call it? Hexagonal. Right. Hexagonal pyramid. Everybody got that? All right. But this is a rectangle. And what determines whether it's rectangular or pentagonal or hexagonal? What determines it? No, not if it's a pentagon, not if it's a hexagon. The bottom of it, the base of it. Okay, remember we did that with the cone? We said the bottom, the circle was a base. Everybody's listening, right? Okay. All right, so the name of it right here all depends on what the bottom or the base is. All right, I don't have a whole bunch of different shapes with 5, 6, 7, 8 different sides on the bottom. I just picked this one, so we'll just use this one. But look what it does. All these sides slant up to that. They call it apex, but we're going to call it the vertex. They all slant up to the vertex. Everybody see that? All right. All this, again, this is just off the internet, so later on there will be a time where we care about the center and the height and all that kind of stuff. Just not today. Okay. All I want to do is for us to be able to recognize what these shapes are just by looking at the picture. Everybody okay with that? All right. So that's a rectangular pyramid. So I could put that on a quiz. I'll put a picture. I probably won't have all those words on there, but I'll put some picture on there that looks kind of like that. And you tell me it's a right rectangular pyramid. If the bottom has how many sides? 4 sides, the base. Okay, I shouldn't say bottom, I should say the base. All right. Here's something else that doesn't come to a point. Look at these. Now, they got kind of cut off a little bit there, but that's all right. Yeah, this is considered to be a prism. You may have done some work in maybe a science class or something with prisms. You ever do that? Take a prism, hold it up to a light, hold it up to the sunlight, and then it refracts. Door, please. Doesn't seem like I have everybody's attention, okay? I need everybody's attention. So if you take a prism and hold it up to the sunlight, it'll go through, and I think the correct word is refract. It'll refract the light, okay, into the spectrum, the color spectrum. Do you know what the color spectrum is? Roy G. Biv. Have you ever heard of Roy G. Biv? Red. Red, orange, yellow, green, blue. What's the I? Indigo. I had a professor in college that says there really is no color indigo. We just put the I in there just to make the Biv sound better. So I don't know if that's true or not. I should look it up someday. All right, indigo what? Violet. Okay, so that's the spectrum. Anyway, you could take something like this, like a prism, and hold it up, and it'll break it down into the rainbow colors. Okay, it's kind of cool. Anyway, but that's what a prism is. Look at the difference. Look at the prism compared to the pyramid. The pyramid, all right, this has a rectangular base, and so does this. It has a rectangular base. But what's happening to the sides though? They're just going what? Just straight up. Yeah, straight up. Okay. And on the top, look at the top. It doesn't come to a point, does it? All right. The top is the same as the bottom. So really it has how many? We talked about this with the cylinder. It's got two bases. Okay. It's got two bases. Not just the one that it sits on, but the one that's on top is considered a base as well. All right. And the sides are just called sides. Yep. All right. You could have oblique. Remember what an oblique does? It just slants, right? Instead of just going straight up at a 90-degree angle, these slant. All right. And there you go. This is a rectangular prism. This is a triangular prism. What's the difference? That's it. You got it. One of the bases is a triangle and the other base is a rectangle. Good. All right. Everybody with me? So do you see the difference between a prism and a pyramid? All right. Think of pyramids. Where, Natalie? Where are the pyramids? Yeah, you were the one that's so excited about it. I thought I'd give you a chance to answer. So the pyramid is in Egypt, right? And you'll see it. I don't know. We could look it up, but I'm not going to because we're running out of time. But you could look it up and see what kind of pyramid it is. Okay, are they all rectangular pyramids? I don't know. They may be. They might not be. I don't know. My guess is they probably are. That'd be my guess. All right. Anybody been to Egypt? No? We haven't. You have?
You were in Egypt?
Oh, you're lying so much. All right. We have a girl here. Open the door, please. Somebody open the door real quick so he doesn't have to. Quick. Yeah, it feels better. Maybe because I just turned it up, I think, a degree. Because like at 70, when it settles in, it's freezing cold. But I turn it to 71, and then it gets like way too hot. I wish there was like an in-between. But beggars can't be choosers, right? Yeah. All right, appreciate it. Thank you. All right, so there we go. We got that. Now, here's for some weird things. I'm just going to delete these. Okay. Now, I don't really expect you to draw those things. They're kind of hard to draw. That's why I grab them off the internet, because I can't draw those things. I'm a terrible any kind of artist. But let's do this. Here, check this one out. I'll just move this over and just paste it on. Oops. Oblique. Yeah, you could, sure. Yep. Oblique. Yep. A slanted. Oblique. If it's slanted, well, it's called whatever the shape is. Okay. You could have an oblique pyramid. You could have an oblique cone. You could have an oblique cylinder, right? Which one? The other one that I had? I don't know. What was it? Rectangular? Oblique, rectangular? Prism? Yeah. Okay. They're all in the book, okay? Because I just picked the ones that they show pictures of in the book. So I put those. All right, look at this thing. This, right, it does have a triangle that comes to a vertex and all that, but they call this, look at this crazy name. So we're going to have a lot that have this little suffix. Is that the end, right? Prefix is the beginning, and I think. Is that right? Suffix? So hedron. Okay? So this is tetra. Tetra is another word that means four. Okay? So there's 1, 2, 3, 4 of these faces. Okay? They call it a face. All right? So if it has 4 faces, or 4, I guess you could call them sides. You could think of them that way. All right? But if you look at it, it's a 3-dimensional thing, right? Now you don't see the third one, do you? You see 1, 2, 3, but you know there's one on the other side. All right? So you can't show everything on 2-dimensional, space like this. But they call that a tetrahedron. Notice, it has 4 faces. It's got 4 vertices, right? There's 1, 2, 3, 4. Yep. And then it's got 6 edges. Edges are these straight lines right here. This one says 6 of them. So there's 1, 2, 3, 4, 5, 6 right there. It's a tetrahedron if there's 4 faces, okay? Not really, because any of the faces could be considered the base, all right? I believe they call this a regular tetrahedron, which means all the faces are the same shape and the same size. Okay, all right. But that's a tetrahedron. Tetra meaning what? Four. Okay, you don't hear that very much, do you? For a prefix, but tetra means four. My word. All these people. Let's do another one. Again, I'm just gonna for the what am I trying to say? I have no idea. Okay, let's do both of these. This lesson's kind of a mess, but that's okay. Now, this is the same shape, but what do? They just sliced it in the middle, right? Okay, just to show you what it's made up of. All right. So this looks like a what? A pyramid, doesn't it? And that looks like a pyramid. You put those two pyramids together at the base, and you got this thing right here. So let's count how many faces this thing has. Again, you can't see them all. 1, 2, 3, 4. And then how many on the back where you can't see it? 4 more, so there's 8. Okay, so take a wild guess. It's an octo. Is it octo or octa? I think it's octa. Let me see the word. 8. Octa. Yeah, I was right. Octahedron. All right, when it's this kind of thing, there's a definition for it, but the definition is probably more confusing than anything. All right, but if you see a shape like this and it's got 8 faces, all right, then we call that a octahedron. Everything ends in a hedron. All right, that's all you got to remember. So when they look like this, it ends in this word, hedron. You can say hedron or hedron. We just kind of get a little quick and a little lazy with it and just say octahedron. A what? Oblique. Probably. Let me see what it says. It's a closed surface. I'll read off the thing. A polyhedron. A polyhedron. I didn't say that word. Poly meaning how many? Yeah, many. All right. Polyhedron. So these are all polyhedrons. All right. Poly is just a general word for having a bunch of faces. All right. Let me just read the definition. I'm not going to write it down. I'm not going to make you memorize it or anything. It says polyhedron is a closed surface made up of polygonal. All right, meaning polygons, a bunch of polygons, polygonal regions. Each polygonal region forming the surface is a face of the polyhedron. So that does make sense. So this thing right here, right, that thing is a face, this is a face, that's a face, and so on. Okay, that's all that is. What's that? It's just the design. Yeah, it's just how they drew the picture. Okay, everybody good with that? All right, let's do a couple more. I'm not going to give them all. They give a list on page 41 of all the prefixes and the names of all the hedrons, right? The polyhedrons. Let's see. Okay, we already did that one. We did that one. Oh, let's do this one. It's kind of easy to count because you can count all the ones that you actually see, and you know there's going to be that many on the other side where you can't see, all right? So it's not that hard to see. And they call it a dodecahedron, all right? So let's count how many we got. We got 1, 2, 3, 4, 5, 6. Yep. So there's 6 that we can see, right? But then there's 6 that we what? Can't see. So how many sides are there? There's 12. So that's 12 sides. Remember we did dodecagon not too long ago? Well, it's the same thing. It's the same prefix. Okay, the dodeca is 12. What would be a 10-sided one? Just a decahedron. Right, good. All right, so this is 12 sides, so it's a dodecahedron. I don't know. Do meaning 2 plus 10? I don't know. I don't know what maybe that's what I was thinking, since it's dos, but I don't know. So, but anyway, dodeca is 12. So if you have 12, I shouldn't say sides. What should I say? Faces. Yeah, I should have said faces, shouldn't I? Whatever. Anyway, you can write that in there. It's too much trouble to do that. And I think I have another one. I think I might have gone big first. Oh, yeah, that one. That's a weird one. I had to practice saying that because this is crazy. Again, we're not really going to do anything with this year. All we want to do is just know what the names are. That's all it is. All right, let's count. How many? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So there's 10 you can see. Shh, smart, up here. There's 10 you can see, 10 you can't see. So how many altogether? There's 20. Now, this is a weird prefix. Now, I'm going to write faces this time. All right, so there's 20 faces, all right? And Icasa, I-C-O-S-A, and then what? Hedron. Yeah, icosahedron, okay? Again, I've never really worked with this stuff. I'm sure people do, and I'm sure there's people that know all about these things, but we call that an icosahedron, all right? So basically, if you can see the picture and describe it, or, somebody said, what's a 20-faced polyhedron called? You say icosa or icosahedron, okay? Same thing with all the other ones, right? And then I might put a picture on a quiz or a test, right? And I'll say, all right, what is this a picture of? And then you write the word, okay? I'm not going to give you a word bank. It's not going to be multiple choice. You got to know the word. So know your prefixes. If you know your prefixes, then it's pretty easy because you just stick hedron after the back of everything, okay? So on page 41, there's a list. I didn't put them all on there, but all the prefixes are exactly what we've talked about before, except for 4. It used to be we call it a quadrilateral, but on this one we call it a what? What hedron? A tetrahedron, not a quadrahedron, a tetrahedron. Okay, so you have a little assignment, right? What did I give you for this? 1 to 32. Oops. I don't know. It's section 1-7. 42 and 43. 42 and 43. What did I say was? Numbers what? 1 to 32. Correct. Yeah. A lot of it's not like you got to do any math, right? You just read the problem, write down an answer, and most of them are pretty easy, all right? So you don't really have to do any math on this stuff. So do what? Well, it's not all going to be that. Sometimes they'll describe it in a sentence, and you got to tell what word they're describing or something like that, okay? Yes, it did. All right, so we may or may not have the test on Friday. I'm thinking in my head that we had a quiz last year before we took this test. So I'll have to look to see. We may have a quiz first before we take the test. We may. I'll have to look. It probably won't be tomorrow. If we have a quiz, it won't be tomorrow. Okay, it'll be. So there's possibly a test or a quiz Friday.
Okay, but
possible. But I got to look because I just can't remember.
And nothing tomorrow, right?
No test or quiz tomorrow.
Okay.